Welcome to AI Frontiers, navigating machine learning's latest breakthroughs. In this special episode, we synthesize 70 new machine learning papers from the cs.LG category, all published on a single day. Join us as we uncover emerging themes, explore impactful technical advances, and examine their societal implications. We will spotlight a standout study by Lan and colleagues, connecting these research developments to real-world questions of trust and transparency. This is your guided tour through the evolving landscape of artificial intelligence. Can AI's answers be secretly manipulated? Today, the importance of trust in artificial intelligence is more critical than ever. Imagine conversing with an AI assistant, unaware that its responses are subtly influenced by hidden signals. Recent research confirms this risk is not science fiction, but a present reality. As advances in machine learning deliver both promise and new vulnerabilities, consider, what would it take for you to trust an AI's decisions? Keep this question in mind as we explore the frontiers of machine learning. Today's exploration focuses on breakthroughs from 70 cs.LG machine learning papers released on September 15, 2025. The goal is to illuminate not only what these advances are, but also why and how they matter. This journey introduces researchers addressing both foundational and real-world challenges, driven by curiosity and a desire for impact. By the end, listeners will gain a panoramic perspective on the current state of machine learning and insights into its trajectory. Think of machine learning as a dynamic, bustling city. Algorithms form the streets, data constructs the buildings, and models act as the residents, each learning and adapting. The cs.LG community functions as city planners, integrating mathematics, computer science, and domain expertise. Machine learning, once limited to simple pattern recognition, now powers technologies such as autonomous vehicles and scientific discovery. The field evolves rapidly, with new research and fresh challenges emerging daily. Like a city constantly under construction, machine learning remains vibrant and ever-expanding. The first major theme is robustness and trustworthiness, akin to constructing reliable bridges. Robustness ensures that models remain stable, even when faced with attacks or changes in data. Unlearning, as demonstrated by Kumar and collaborators, allows for the removal of dangerous or unwanted facts while preserving the core functionalities of the model. Defense strategies are being developed to patch vulnerabilities, much like repairing structural cracks in a bridge. Notably, selective memory erasure methods now achieve up to 8 times greater effectiveness, analogous to erasing graffiti without harming the underlying wall. Foundation models represent the Swiss Army knives of artificial intelligence. These models, as shown by Zhang and colleagues, are trained on vast datasets and can be adapted across diverse domains, including text, images, and scientific tasks. The principle of train once, use many times underpins their versatility, much like a multi-tool applied to various challenges. Foundation models now forecast weather, interpret neural activity, and more, leveraging transfer learning to apply acquired knowledge to new tasks. Scalability and flexibility are central to ongoing innovation in this area. Interpretability and fairness mark the next theme, reflecting AI's growing role in critical societal decisions. Transparent models, such as those studied by Lee and Associates, allow users to understand how AI reaches its conclusions. Fairness is especially crucial in domains like hiring, healthcare, and justice. Explainable boosting machines now approach the accuracy of traditional black box models, providing step-by-step explanations. Model interpretability, demonstrating the reasoning behind decisions, builds trust and ensures accountability in AI-driven systems. Key findings from this research corpus illustrate the breadth of recent advances. Lan and collaborators reveal that subtle attacks can hijack an AI's preferences through imperceptible modifications. Foundation models, as shown by Patel and colleagues, uncover hidden dynamics in brain data. Chen's team employs random Fourier features to accelerate and improve the accuracy of mathematical problem solving. Kumar's group demonstrates efficient techniques for removing harmful knowledge from models, while Lee and colleagues illustrate that transparent models can predict job market outcomes as effectively as opaque alternatives. A highlight from the corpus is the paper Preference Hijacking in Multimodal Large Language Models at Inference Time by Lan et al. This study investigates whether the outputs of large language models can be influenced by images without accessing or altering the model's code. The attack utilizes almost invisible changes to images, causing the model's responses to subtly reflect the attacker's intended preference while still appearing normal to the user. This raises significant concerns regarding AI safety and the reliability of multimodal systems. The mechanics of this attack can be likened to a magician's sleight of hand. Images serve as distractions, embedding hidden cues that steer the model's responses. A universal perturbation operates as a master key, enabling consistent influence across multiple images, tasks, and prompts. The model's answers shift subtly, remaining undetected by users and standard monitoring tools. This highlights the complexity and urgency of defending against such stealthy and hard-to-detect manipulations in AI systems. The implications of this research extend beyond technical novelty. The authors, Lan and colleagues, have openly shared their code to encourage the development of robust defense mechanisms. Importantly, the attack does not generate obviously incorrect outputs, complicating detection. The ongoing contest between attackers and defenders in AI security is reminiscent of a cat-and-mouse game. The research community is invited to identify, analyze, and patch vulnerabilities, motivated by the goal of not only exposing flaws but also enhancing the safety and integrity of AI systems. Looking to the future, machine learning is likened to a ship navigating uncharted waters. Foundation models are poised to become the backbone of adaptable and robust AI. Integration of scientific theory and data-driven approaches, such as leveraging physics to inform climate models, is accelerating. New evaluation benchmarks now emphasize robustness, fairness, and trustworthiness over mere accuracy. Efficiency improvements will soon make AI accessible to more users worldwide. The journey ahead involves charting new challenges, addressing societal needs, and exploring promising horizons. In conclusion, today's research brings the field closer to the realization of trustworthy and explainable artificial intelligence. Robustness and interpretability, as advanced by Lan, Kumar, Lee, and others, have become central concerns. Each breakthrough contributes to an ongoing collaborative dialogue within the AI community. Curiosity and engagement from listeners and researchers alike are essential in fueling the next wave of discovery. Everyone is invited to explore, question, and actively participate in the ongoing evolution of machine learning. This presentation was crafted through a combination of advanced AI tools and expert human oversight. Specifically, GPT 4.1 from OpenAI was utilized to synthesize and summarize the extensive research corpus. Text-to-speech synthesis leveraged OpenAI's capabilities, while visual summaries were generated using Google's image technologies. All content was reviewed by a human expert to ensure clarity and technical accuracy, though minor oversights may persist. Listeners are encouraged to consult the cited references for comprehensive details, as all referenced papers are acknowledged throughout this session. Thank you for joining the AI Frontiers community. To stay updated on the latest breakthroughs in artificial intelligence, subscribe for more in-depth explorations of cutting-edge research. Your questions and insights are always welcome in the comments. Stay informed with daily updates on machine learning and AI advancements. Channel AI Frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.